Okay, so if we were in my class, you would do a lab, which is very common for AP Environmental Science students nationwide. Um, if we were in my classroom, this would be a full day lab. We would probably have on the whiteboard a drawing of the dissolved oxygen curve with the zones of a river. And if you were in my class, you would be working in groups of 3 and you'd have some material. I'm going to try to do this whole thing for you, and I'm going to pause in between the steps, and I don't do that a lot, so hopefully that's not clunky. But first, I'll give you a tour of my lab equipment. I've got plain old milk that's in a little glass that we have from my house. That's just milk out of the fridge. This is clean drinking water that's been left out overnight to off-gas any chlorine from water treatment. I've got a few of these thingies to measure, graduated cylinders to measure. I've got a test tube rack with a bunch of test tubes that have a piece of tape on each one. And so far I haven't, but soon I will label my test tubes 1 through 6. I've got corks for all of them. I've got this extremely strong smelling bottle of yeast. This is baking yeast, the stuff that you might use to make bread. And I have been nurturing this all morning. So this is warm. I put it on a stirring hot plate. There's a magnet in here. Yeah, you can't quite hear it, but there's a magnet in the inside of this jar. So the magnet underneath my hot plate moves, and this has been getting stirred. So I've been feeding oxygen to this yeast and getting it warm and lively. Oh God, I hate that smell. Plus my man cave smells because I've been varnishing gaffs, and so it smells like spar urethane varnish and also yeast. It's not a pretty space right now. All right. Last thing I've got is this really weird chemical. It's called methylene blue. Fun thing about this chemical is it stays blue whenever there's oxygen around. This is an oxygen indicator. I'm going to pause, and then I'll come back when I've started to put some things together. Okay, during the break, I added 5 milliliters of water to these, and this one over here, number 1, is so far empty. In that one, number 1, I'm about to add 10 mils of milk. So number 1 is now 100% milk. And I'm going to take some of that milk out. So 100% milk in number 1. And I'm going to use the milk I took out from 1 plus the water in 2 to make 50% milk, right? Because this was half water, half milk. Usually, I would be sitting around at the front of my classroom watching you work, making fun of some of the kids, sabotaging some of the kids, probably taking a bathroom break. Now I gotta actually do this lab. Okay, so this is 50% milk, and this is tube number 3. And I'm gonna cut that 50% milk with water, right? This was 50% milk, but now I mixed it with water, equal volumes. So this is now 25% milk. I'm going to put that back into, half of that back into a graduated cylinder. And I'm going to take that and I'm going to pour it into test tube number 4. All right. I will pause and then I'll show you where this takes me, okay? I'm almost done pausing. Okay, now I'm back and I have created test tubes 1, 2, 3, 4, 5, 6 with what we call a serial dilution of milk. So I have diluted it in sequence. So that's 100% milk. That's 50% milk. That got cut in half with water, so that's 25% milk, and I took some of that 25 and put it in here, so this is 12.5% milk. And I took half of that and I cut it with water, so this is 6.25% milk. And this is just water, plain old water, okay? So that's a serial dilution, more milk, less milk, okay? And now I'm gonna try really hard not to stain myself. I always laugh at my students. This purple stuff stains for life. Like your skin will be blue until it comes off. Okay, I'm gonna put 1, 2, 3 drops in each of my test tubes. These are really big drops. All right. And you can tell that everything is mellow here because, you know, all of these have oxygen in them. This was recently stirred. So the blue merely indicates it's nothing special. It just tells us that there is oxygen in that liquid. So there's our control group. 6 is just water. Number 5 is about 6% milk by volume, and that's blue because, you know, no big deal. There's plenty of oxygen in number 5, 4, 3. These all are blue because they all have oxygen. So that dissolved oxygen we were talking about, remember that's not the oxygen of H2O, it's just oxygen spaced out in between the water molecules. Okay. I'll be back in just a minute and we're gonna start some timers and get the party started. Here we go. Be right back. And what I have now is this beaker full of activated yeast. It's warm, it's on a heated stirring plate, and it's frothy. You can't see it, but there's like foamy bubbles inside of here. This yeast will represent decomposers. This will be the decomposer in my system. So this yeast is going to be the microbe that eats the sugar which is found in milk. Milk has sugar. That's why you're not supposed to drink milk before you go to bed. They used to tell kids to drink a glass of milk before bed. It's supposed to strengthen their teeth because of the calcium. Apparently that gives you cavities. It was bad advice when we used to tell children to drink milk before bed. All right, watch this. I will now add to number 1 some yeast. I will cork. I will agitate to get everything mixed. And then I'm going to write down my start time. 7:28. I'll repeat. And I'm not going to make you watch me do that. But anyway, I just added yeast to number 2. I'm going to stir it up. And I'm going to write down my start time for number 2, which is 7:29. And I'll stop, and I'll bring you back in just a minute to show you what I'm up to. Okay, children, so I'm done building the lab and all the all the times are recorded. And here's what I have made. A serial dilution of milk with blue oxygen indicator. And I have added a population of aerobic decomposers. In this case, I used yeast. You can imagine I'm giving food to things that breathe oxygen as they eat. So, you know, I've used something that's biodegradable, milk, to feed decomposers yeast. And the blue should indicate for me oxygen levels. Now I'm gonna chill. Probably won't take too long. Gonna answer a couple of emails. I'll see you in just a minute, I think, just a few minutes. Okay, so it's been a couple of minutes, about 10 minutes since I finished the setup, and I wanted to check in just to show you something. I think maybe you can see, wow, I realize on the screen these colors don't have the same gradient that they do in real life, but anyway, you can kind of see that we're getting some separation. So the water and the milk are separating. And we're also getting some oxygen consumption. So these yeast are using oxygen that was dissolved in that liquid. They're using that oxygen to digest the sugars that are in milk. And that means that the yeast must be doing something with that sugar and that oxygen. They're doing cellular respiration. So you should probably imagine what they're adding to this water. If they're taking out dissolved oxygen, then they must be adding dissolved carbon dioxide. So maybe you know that beer is carbonated by the activity of yeast. That's why fermented drinks get fizzy. Wine is allowed to release all of those bubbles. But you know that if your wine is lively, it'll actually get some fizz. That's what like champagne is. And anyway, you can see that this one that had the most milk is turning white the fastest. It's losing oxygen more because there's more stuff to eat here. So my gradient of milk concentration is probably becoming a gradient of oxygen left. With 0 milk, this should probably stay blue because there's nothing for the yeast to eat except each other. They technically will still have something to eat. And then this should have kind of a lot of oxygen and less oxygen and less oxygen and very little oxygen. And this will run out first because it's got the most food for them. Usually I use fresh yeast. This year I used year-old yeast, so maybe that's why it's a little bit slower than usual. We'll come back in a few minutes to see if this actually gives us something more to talk about. Okay, so the results that I am getting are almost completely white, the one that had the most milk, almost completely blue, the one that had no milk, and a gradient of blues here. Now that staggering is a little surprising. I don't know, maybe different temperatures. The milk was cold, the water was, maybe that's why they're not mixing. But anyway, here's the point. The more they have to eat, the more oxygen they consume. That's really all I needed to show you with this. But there are a couple of interesting tricks. When I was setting up, I had a little secret on the side set up. A little secret where I made one beaker that is more pronounced. This one has double the yeast of the others. You can see it's taller than the ones I had earlier. And you can see that it's all white, which means the yeast have used up all the oxygen. But I want to show you something. I'm going to wrap this up in a paper towel because I don't want to shoot this dye all over my workshop. But there's still oxygen up there. So when I shake this up, that should turn back to blue. See, I have added more dissolved oxygen because, you know, I forced the atmosphere to interact with the milk. And by giving these yeast more oxygen, then they're like, oh, great, now we can get back to work. And if I sit here for just a few minutes, I can see it happening. I realize that the screen, this labs from where you are, I know it really sucks. But anyway, I can see that at the very bottom, it's already turning white, where most of the yeast have settled. They're using up the oxygen. And if I could just find something to babble about for 2 or 3 minutes, this whole thing would turn white again. Interesting that the only thing we need to provide for the decomposers to use up their food is oxygen. These are aerobic decomposers. They're using aerobic decomposition, so as long as we're aerating, then they're going to keep doing their jam, right? So if I shake it up, I have now added more oxygen. It turns blue. And by giving them more oxygen, I should be able to see them. Yeah, there we go. Oh man, it's a bummer that you can't see this because it's kind of neat. They're getting so active that this is getting fizzy. You can kind of see it's making like a head on top. So pretty soon, because I super loaded this one, I can see little tiny CO2 bubbles rising out. They have saturated this with CO2. So now this is carbonated. As long as I keep feeding them oxygen, they're going to keep eating all the sugars. Oh man, I see so many little bubbles now. They're going to keep eating all the sugars. They're going to use up all the oxygen. I give them more oxygen, they do more work. Soon, there will be no sugar left. soon they will make so much CO2 that this cork will pop off. And the only thing that this requires to decompose the milk is oxygen. So fun fact number one, the only thing that we have to add in wastewater treatment is oxygen. Everything else is just bacteria decomposing organic compounds. Wastewater treatment doesn't require any addition of anything. There are steps where they add chlorine before they release it to the ocean so people don't get bacterial infections or whatever. But for the treatment of wastewater to digest organic compounds, all that they add is oxygen. That's why the wastewater facility is Santa Barbara's largest electricity user, because they run a bunch of pumps to keep the atmosphere interacting with wastewater. That's also why a lot of canals in Europe have like little staircases in them so that they can oxygenate the water to encourage decomposition of organic compounds as the water moves through a canal in a city. That's why when I go to the Sierra, I always drink wild water, but I don't drink stagnant water. I drink super oxygenated water. Bottom of a waterfall, maybe? If you ever see movies where somebody goes and they're drinking water out of a stream, they're usually looking around to find a place where it's really bubbly and active, a lot of surface activity. Because by dissolving more oxygen into it, you're feeding decomposers that are going to use up all the organic stuff that you don't want to drink in your water. I'll stop now, but I'm making fizzy milk. At some point, they might actually start making alcohol, this yeast. And if I remove this cork, it might pop. Let's see. Okay, I don't know if you heard that, but there was a whole bunch of bubbles coming out when I opened it. Anyway, this was the dissolved oxygen lab modified for our class, COVID times. You can see that while I was talking, number one turned fully white. It had the most milk. Again, if I feed it oxygen, it'll turn blue again because blue indicates oxygen levels. And you can see that there's like a spectrum of how blue. You can see that these ones are starting to use up the last of the oxygen in this one because it was 50% milk. And that kind of matches that drawing that you had of the different zones, how oxygen level is consumed differently depending on how much stuff there is for microbes to eat. And I'm glad you got to see this. I'm sorry that we don't get to do labs like normal. Thank you for watching this video today.